Assalamu alaikum student. I hope you all are good. In today's lecture, we are going to start unit number 2, which is system of real numbers, exponent and radicals. In the previous chapter, we have learned some different types of sets of numbers. Let us recall them. The set of natural numbers. The set of natural numbers contains all the counting numbers starting from 1. Set of natural number has 1, 2, 3, 4, 5, 6 and so on. Then we have learned the set of whole number. The set of whole number contains counting numbers and 0. Then the set of integer. The set of integers have 1, 2, 3, 4, 5, 6, all the positive numbers, 0 and all the negative numbers, -1, -2, -3 and so on. The next is the set of rational number. The set of rational numbers contain all those numbers that can be written in fraction form. It may also include the numbers, the decimal numbers which are terminating decimal numbers. Then the set of irrational numbers. This set contains such numbers which cannot be written in fraction form, or we can say non-terminating decimal numbers or radical numbers. These all are included in the set of irrational numbers. If we make a set of all these numbers, then that set is called the set of real numbers. The set of real numbers include every number, all the integers, negative, positive numbers, rational and irrational numbers. If we combine all these numbers, we will get a set of real numbers. Next, we have terminating decimal fractions. Terminating decimal fractions are the decimal fractions which has a finite number of digits after decimal. Here are some examples. 0.25. It is equals to 1 upon 4. Terminating decimal numbers can be written in fraction form. That is why they belongs to the set of rational number. To convert a terminating decimal into a fraction, we just remove the decimal and put 1 in the denominator, and then put as many zeros in the denominator as there are digits after decimal. So it will become 25 upon 100, and when we reduce it, we will get 1 upon 4. In the same way, you can convert a terminating decimal fractions into fraction. Next, we have recurring decimal fraction. Recurring decimal fractions are non-terminating decimal fractions whose decimal part contains some digits which are repeated again and again in the same order. They can be written in the form of P upon Q. This is an example of recurring decimal. Here we can see that 5 is repeated again and again. This is a non-terminating decimal fraction and 5 is repeated again and again. So this is a recurring decimal fraction. Then we have non-terminating, non-recurring decimal fraction. A non-terminating decimal fraction in which digits in the decimal part are not repeated in the same order. Such numbers are called non-terminating, non-recurring decimal fractions. They cannot be written in the form P upon Q. Here are the examples. Square root 2, square root 3. These all are the non-terminating and non-recurring decimal numbers. So they are included in the set of irrational numbers. Next, we have the properties of real number. The first one is closure property. A closure property with respect to addition. According to this property, sum of two real numbers is also a real number. That is, x comma y belongs to the set of real number, implies x plus y belongs to real number. It means if we consider two elements from the set of real number and if we add them, we will get a real number. Closure property with respect to multiplication. Product of two real numbers is also a real number. That is, xy belongs to real number implies x multiplied by y belongs to real number. If we select two numbers from the set of real number and multiply them, we will get a real number. You may take any example. If we consider 2 and 3 and multiply them, we will get 6. 2, 3 and 6 all are real numbers. Commutative property. We have also learned commutative property in unit number 1 for union and intersection of sets. Here we have commutative property with respect to addition. xy belongs to real number and xy are the two real numbers implies x plus y equals y plus x. We will get same result if we add x and y, or if we get y and x, we will get same result. You may take any example. For example, 2 and 3, we have chosen two numbers 2 and 3 from the set of real numbers. 2 plus 3 is 5, also 3 plus 2 is 5. So commutative property is verified. Commutative property with respect to multiplication. xy belongs to real number implies x multiplied by y is equals y multiplied by x. You can take the same example. 2 and 3 are the numbers which belongs to the set of real numbers. If we multiply 2 by 3, it means 2 multiplied by 3, we will get 6. Or 3 multiplied by 2, we also get 6. Next we have associative property. With respect to addition, x, y and z belongs to real number are the three real numbers. Y plus z plus x is equals to x plus y plus z. We have also learned this property for union and intersection of sets. In the same way, we have associative property with respect to multiplication. X, y, z belongs to real number. Y, z, if we multiply y and z first and then multiply with x, we will get the same result as when we multiply x with y and then multiply z with it. Next we have distributive property. Distributive property of addition over multiplication. X, y, z belongs to real number. There are three real numbers. Yz plus x, if we add x in the product of y and z, we will get the same result as if we add x and y, x and z and then multiply both of them. This was addition, distributive property of addition over multiplication. In the same way, we have the distributive property of multiplication over addition. Identity, additive identity. For example, x belongs to real number. X is any real number implies x plus 0 equals to 0 plus x is equals to x. If we add 0 in a number or add any number in 0, we will get the same number in the answer. It means 0 is the additive identity. If we add 0 with any number, we will get the same number. So 0 is the additive identity of real numbers. Multiplicative identity. X belongs to real number implies x multiplied by 1 equals to 1 multiplied by x is equals x. It means if we multiply 1 with any number, we will get the same number in the answer. So 1 is the multiplicative identity of real numbers. Inverse. Additive inverse. For every x belongs to real number, there exists an element x dash belongs to real number such that x plus x dash equals x dash plus x is equals to 0. It means for every real number, if we select a real number, there must be another real number such that if we add those numbers, we will get 0 in the denominator. Let us take an example. Consider we have a number 3. We want to add it with any other number such that the answer is 0. Let's think of a number. When we add 3 with it, we will get 0 in the answer. So, such number will be minus 3. If we add 3 with minus 3, we will get 0. It means to find the additive inverse of 3, we have just reversed its sign. Here the sign of 3 is plus, so its additive inverse is minus 3. To find the additive inverse of any number, we just reverse the sign. If you have to find the additive inverse of minus 3, then the additive inverse will be plus 3. Only the sign of the number will be changed and the value will remain same. Now, multiplicative inverse. For every x belongs to real number, there exists an element x dash such that x multiplied by x dash equals to x dash multiplied by x is equals to 1. It means for every real number, there must exist another real number such that when we multiply those numbers, we will get 1 in the answer. Let us take an example. We have a number 5. We have to multiply it with another number such that the answer is 5. Now think any number. When we multiply 5 with it, we will get 1 in the answer. The number will be 1 upon 5. Here we can see that when we multiply 5 with 1 upon 5, we will get 1 in the answer. This 5 and this 5 will be cancelled out and we will get 1 in the answer. It means to find the multiplicative inverse of any number, you just have to reciprocal it. If you are asked to tell the multiplicative inverse of 5, it will be 1 upon 5. If you are asked to tell the multiplicative inverse of 1 upon 5, then it will be 5. It means only the number will be reciprocal and the sign is remain same. In additive inverse, we just change the sign and the number remains same. In multiplicative inverse, we reciprocal the number and sign remains same. Next we have trichotomy property. For any two real numbers x and y, either x is less than y or x is equals to y or x is greater than y. If we consider two real numbers, then only these three relations are possible between those numbers. Either the first one is smaller than the second one, or both are equal, or the first one is greater than the second one. Only these three relations are possible among two real numbers. Next we have properties of equality of real numbers. The first one is reflexive property. According to this property, if we consider x as a real number, then x is equals to x. X will be equals to itself. This is the reflexive property. Next, symmetric property. If we consider two numbers x and y which belongs to the set of real numbers, then x equals y implies y equals x. If we consider two real numbers such that x is equals to y, it means then y is also equals to x. This is the symmetric property. Next we have transitive property. X, y, z belongs to real number. Now we have chosen three real numbers. X is equals to y and y equals to z implies x is equals to z. It means if we have selected three real numbers and x is equals to y and y is equals to z, it means x is equals to z. Additive property. X, y, z belongs to real number and x is equals to y. If we add z with x and y both the sides remain same. This is the right addition because we have added z in the right side. When two things are equal and we are adding same thing with both of these numbers, the answers will remain equal. If we add the number to the left side, it will be called as left addition. Next is multiplicative property. It is exactly same as additive property. X, Y, Z belongs to real number. We have chosen three real numbers and X is equals to Y. If we multiply both X and Y with Z, the answers will remain equal. This is the right multiplication because we have multiplied Z with X and Y to their right sides. Same happens with left multiplication. Cancellation property. Cancellation property with respect to addition is actually the inverse of additive property. X, Y, Z belongs to real number. X plus Z equals Y plus Z. So we can cancel this plus Z from both the sides and we will get just X equals Y. This is the cancellation property, right cancellation property, because we have cancelled plus Z from right side. Same happens with the left cancellation. Now cancellation property with respect to multiplication. It is the inverse of multiplicative property. X, Y, Z belongs to real number. Xz is equals to yz. We can cancel out this z from both the sides. We will get just x is equals y. This is the right cancellation because z was written to the right side. In the same way, we have left cancellation. These properties are also given in your book. Next, we have the properties of inequality of real number. Previously, we have learned the properties of equality. Now we have the properties of inequality. First one is Archimedean property. According to this property, if x is less than y and x is greater than 0, x is less than y but x is greater than 0, then there exists a natural number n greater than 1. The number should be greater than 1 such that nx, it means when we multiply that natural number with x, the answer will be greater than y. Firstly, x was less than y, but when we multiply x with that natural number, the answer will be greater than y. Here are the examples. For example, 5 is less than 14. Now we can take n is equals 3 such that 3 multiplied by 15 is equals to 15. Now this 15 is greater than 14. In the same way, you can check the second example. Transitive property. Transitive property of inequality is exactly same as the transitive property of equality of real numbers. X, Y, Z belongs to real number. X is less than Y and Y is less than Z implies X is less than Z. When X is less than Y and Y is less than Z, it means X is also less than Z. This is the transitive property. Here are the examples. Now we have additive property. It is exactly same as the additive property of equality. X, Y, Z belongs to real number and X is less than Y and we are adding a same number to both X and Y. Then the number which was smaller first will also remain small and the number which was greater will also remain greater. This is the right addition and this is the left addition. This is the example. Next we have multiplicative property. It is exactly same as we have learned for equalities, but there is a slight difference. X, Y, Z belongs to real number. There are two cases. If Z is greater than 0, here Z is greater than 0, it means any positive real number. X is less than Y and we are multiplying both X and Y with Z, right multiplication. The smaller side will still remain smaller and the bigger side will still remain bigger. This is the multiplicative property when z is a positive integer, when z is greater than 0. If z is less than 0, it means any negative integer. Then x is less than y. When we multiply both of them with a negative number, what happens? This inequality reverses. Previously, x was smaller than y, but when we multiply it with z, when we multiply z both the sides, the smaller side is now become greater and the greater side is now become smaller. Multiplication by a positive real number does not change the sign of an equality. This one, when you multiply with a positive real number, the inequality remains same. But multiplication by a negative real number changes the sign of the inequality. This case, when z is less than 0, then the inequality reverses. Now we have exercise 2.1, question number 1. Which properties of real numbers are used in the following example? Letter x, y, z stands for real numbers. You have to identify which properties are used in these examples. 0.4 plus 9 is equals to 9 plus 0.4. This is the commutative property of addition. Second one, x plus 1 plus 2 upon 3 equals x plus 1 plus 2 upon 3. This is the associative property of addition. 100 plus 0 is equals to 100. This is additive identity because we have learned that 0 is the additive identity. Square root 8 plus square root 3 plus square root 7 equals to square root 8 plus square root 3 plus square root 7. This is the associative property of addition. Part 5, 6.2 plus minus 6.2 equals to 0. This is the additive inverse because we have learned that additive inverse are the number. When we add those numbers, we will get 0. So this is the property. The property which is used here is additive inverse. Part 6, x minus x equals 0. Again, additive inverse because it is actually x plus minus x. Plus minus will become just single minus and the answer is 0. So this is the additive inverse. Square root 3 multiplied by 11 equals 11 multiplied by square root 3. This is the commutative property of multiplication. X multiply y minus z equals xy minus xz. This is the distributive property of multiplication over addition. Do not confuse that there is a minus sign and the property says multiplication over addition. This is actually y plus minus z, which is now become y minus z. So the property which is used here is multiplication over addition. Square root 5 multiply 1 upon square root 5 is equals to 1. This is the property of multiplicative inverse because we have learned that multiplicative inverse of a number is a number. When we multiply those number, the answer is 1. So this is the property used here is multiplicative inverse. Next, square root 3 multiplied by 4 multiply square root 6 or square root 3 multiply 4 multiply square root 6. This is the associative property of multiplication. Minus square root 3 plus square root 3 is equals to 0. This is additive inverse. Question number 2. Which properties of real numbers are used in the following inequalities? Properties of real numbers are used in the following inequalities. Now inequalities are given. Minus 5 less than minus 4 implies 0 less than 1. This is the additive property because we have to subtract, we have to add 5 from both the sides to get this side. That is why this is the additive property because same number is added from both the sides. Minus 10 less than minus 8 implies 20 less than 16. Here we can see that this minus 10 is multiplied with minus 2, and this minus 8 is also multiplied with minus 2 to get this number. So this is the multiplicative property. Minus 1 greater than minus 1 implies minus 3 less than minus 5. Acha, this is the symbol which is shown here is actually wrong. This is the symbol of minus 3 greater than minus 5. So this is the additive property. A less than 0 implies minus a greater than 0. Here we can see that the inequality is reversed. So the property which is used here is multiplicative property, because only in multiplicative property the inequality gets reversed. Same happens here. Inequality is reversed, it means multiplicative property. Same happens here. Minus 1 upon 3 is greater than 1 upon 4 implies minus 1 upon 3 is less than minus 1 upon 4. Again the inequality reverse, it means the multiplicative property. Same happens in part 8 as well. Question number 3. Which of the set possesses closure property with respect to addition and multiplication? In closure property we have learned that if we multiply the numbers of any two sets, the answer must be from that set. Similarly, with respect to the addition. Here the set is given to us 0, comma minus 1. We have to check whether this set possesses the closure property with respect to addition and with respect to multiplication or not. To check we to check the closure property of addition, we will add 0 with 0, and the answer is 0, which belongs to the set A. Okay. Then we add 0 with minus 1, because we have 0 and minus 1 as the set members. So 0 plus minus 1, which is equals to minus 1, which is also belongs to the given set. It means it is also okay. Now we have chosen minus 1. Minus 1 plus 0 is equals to minus 1, also belongs to the set okay. Minus 1 plus minus 1, which is equals to minus 2, which does not belongs to the given set. It means closure property of addition is not satisfied here, because all the answers must come from the given set. But here we can see that minus 2 is not a member of our given set, so the closure property with respect to addition is not satisfied. Now check the closure property of multiplication. Take 0 and multiply it with all the numbers. So 0 multiplied by 0 is 0, belongs to the set okay. 0 multiplied by minus 1, again 0, belongs to set okay. Minus 1 multiplied 0 equals 0, belongs to set okay. Minus 1 multiplied by minus 1 equals to 1, which does not belongs to the set. This is not okay. So the closure property of multiplication is also not satisfied. So we will write the set 0, comma minus 1 does not possess the closure property with respect to addition and multiplication. In the same way, we will check for our second part and third part. And that's it. Our exercise 2.1 is done. Thank you.